Today we're going to train your brain on drawing pictures like you've been doing in the past on drawing vectors. So first we're going to go back and rehash the different ways that we've drawn vectors, and then we're going to talk about a new way and get into today's lesson. Today's lesson is mainly focused on horizontal and vertical vectors. Horizontal and vertical, you can imagine what those are looking like. But going back to what we've seen before, we started with standard form, and standard form is with the positive x-axis going counterclockwise. The second way we thought about this is with bearing, and with the bearing we were focusing on the north-south line, and we had a form that was north-south, your angle, and then east-west. Then we went into something off of due north. So from due north, we may have something like 100 degrees. And then today, what we're going to do is like a story problem where it's going to say, like, you're shooting an arrow with an angle of elevation, or you're shooting an angle or a cannonball, or you have to picture yourself shooting something in the air, and you have an angle, and the best way to measure that angle isn't in bearing anymore, but it's just off of the horizontal. And so today, the new idea is off of the horizontal line, you're shooting an object up, and then that angle is going to be your theta. So it's like from the horizontal. It's not like you can memorize these forms and just go with the form. You have to read the story problem carefully to see how to draw the picture, and that's how you can train your brain on drawing. It's not by memorizing, but actually understanding the story problem. Let's go to the horizontal and vertical vectors. Yesterday we learned that vectors have two components. One is length and the other is direction. That's how it differs from a ray. A ray would only have pretty much direction. A ray doesn't have length. A ray goes on forever. It's just an arrow that looks like it has direction, but a ray will go on forever. A vector actually has a length and has a direction. Rays, you draw it only direction, no length. So let's go back and talk about horizontal vectors and vertical vectors. And today we're just going to be looking at the components, horizontal and vertical components of a vector. So we're going to draw in the vector, and then we're going to find out what the horizontal and vertical components are. It's actually easier than the last lesson. So let's say, for example, in this particular drawing, that you're shooting an arrow up into the air, and from the ground, when you shoot it off of the horizontal, the angle of elevation, or the angle, is going to be 52 degrees. If the problem doesn't say it's bearing or from due north, and it's talking about shooting something in the air, you're now thinking off of the horizontal shooting. Just picture you doing it yourself, and that's an easy way to think about how you're going to want to label it in the drawing. So 52 degrees is going up, and this can be like 10 miles per hour. And the question is, what's the vertical and horizontal vectors? This is vector x, horizontal, vector y, vertical vector. And the way you solve this is simply by using SOHCAHTOA. And so you're going to be using cosine and sine and solving. Remember, this is the notation for the magnitude of the vector. It's in absolute values, meaning the distance. Distances are always positive. This will always be positive. That will always be positive when you're trying to find the magnitude of those certain vectors. These problems are easy. Draw them, draw in the vertical and horizontal, use SOHCAHTOA, and you've got your answer. Then I want to go to a couple story problems, make sure we can set them up and draw them and understand what they're asking for. So the next one is going to be example 3, a cannonball, and this is a little bit shorthand. A cannonball is, let's say, is fired at 50 miles per hour at an angle of 60 degrees from the horizontal. Find the vertical and horizontal vectors. Very similar to what we talked about before. The first thing we want to do is draw it. When I draw it, I want to label everything, and then I want to solve. The key here, from the horizontal, meaning I draw the horizontal, I then draw 60 degrees up, label it at 60, and then I want to find out what the vertical and horizontal vectors are. Meaning I want to draw in those two vectors. I could call one X and the other one Y and just say that they're the vertical and horizontal vectors. But at this point, you certainly don't have to grab your calculator and find that out. The 60 degrees is the clue here that you're now talking about a 30, 60, 90, and you know that this is 50 miles per hour. Use your 30, 60, 90s to solve this quickly. You're going to see opposite 30 is the short leg. It's short of the hypotenuse by dividing by 2. So you know that the short leg is going to be 25 miles per hour. The long leg, which is the vertical vector, is going to be multiplying the short leg by radical 3. So this is going to be 25 square roots of 3 exactly miles per hour. And again, this is going to equal, and you could say this is the vector, horizontal vector or vector at x, and this is the vector at y. And since these are vectors, they're going to have length and direction. So this actually is the length of this object, and then the direction, because it's a horizontal vector, means it's giving you a direction that's on the horizontal. This is a vertical, it's giving you direction in terms of up and down. So it does have both components in it. Example on page 104. And on this example, it talks about an arrow. It's the same type of problem. It says an arrow is shot into the air, so the horizontal velocity is this and the vertical velocity is this. Find the velocity of the arrow. Given horizontal and vertical, find the velocity, the true velocity of the arrow. So drawing this, again, it's an arrow shot up. So it's going to be like an elevation problem. And it says the horizontal is 25 feet per second. And the vertical is 15 feet per second. The question is, find the velocity. Now, velocity means two things. Velocity is a vector, and therefore you have to have two answers on velocity. One is the length, and the other one is direction. That means that I want to have my theta, which is the direction from the horizontal, because it makes sense in the problem. It's the direction from horizontal. And the second one is going to be the length, which is x. Now be careful on this one, because this is 3 times 5, this is 5 times 5, but the hypotenuse is not 4 times 5 because it's not the longest side of the triangle. It's not a 3, 4, 5, even though you have a 3 and a 5 in them. You have to do the Pythagorean theorem in order to find out your x. So x squared equals 15 squared plus 25 squared, solving for x in feet per second. And then the second part of this is what's your theta. The theta is going to be opposite over adjacent. Tangent theta equals 15 over 25. And then you're going to automatically write down this on the second step. All right, so there's going to be two answers. That's going to be your first one is the length, and the angle of elevation, or the angle off of the horizontal, is going to be your second answer for the full velocity. Looking at the last problem, this is example 5, and we just want to read this and make sure that we can set it up correctly. And so again, we're going to take it one step at a time. Turns out to be kind of a lengthy problem, but lengthy in terms of tedious, not necessarily difficult. And so we're going to chug along on this this problem one step at a time, and then we're going to go ahead and solve it. So a boat travels 75 miles on a course with a direction of 27 degrees, and then changes its course to travel 37 miles at 55 degrees. We have it moving, and instead of boat, maybe we should just say train, because today's train and brain day. So a train travels 75 miles on a course with direction of this, and changes its course to travel 37 miles at 55 degrees. How far east and how far north did the train travel on this trip? Draw. Meaning, we're looking at the train with the direction of 27 degrees. Doesn't say anything about bearing. It's from due north again. So we're switching back to that drawing. Meaning I have a north-south line, 27 degrees. At 72 miles. Then, meaning draw another north-south line. Its course travels to 37 miles at 55 degrees. .37 miles. The question is, how far east and how far north did the train travel? You're thinking vertical and horizontal here. And so what you really have to do in this problem is draw in right triangles so you can calculate that distance. And I want to mark each of the components that I want to find. North, north sub 1, north sub 2. East, east sub 1, east sub 2. The question here is, what's the total north and the total east? So therefore, if I were to take my north, the north total is actually going to be north sub 1 plus north sub 2. So I actually have to calculate the north sub 1 using this triangle and the north sub 2 using the other triangle. Now, one other thing that could help you with this is I would say those two angles are congruent, so I would just use 27 degrees, and then you have cosine to find north sub 1 and sine to find east sub 1. And similarly, I would say this is going to be congruent angles, and therefore that angle is 55 degrees. Then to find east total, we're going to take east of 1 plus east of 2. And that's going to give you 2 answers in terms of miles. The most important part on this one is keeping organized and finding the 4 components and adding them up to find total. Keep in mind, there isn't one way to draw these pictures. You have to really read the directions and set them up correctly. That's 75% of the battle. Train your brain to set them up correctly and read the directions carefully.